Welcome to Module 3, Lesson 8. We are going over our fourth and final conic sections, which are parabolas. To prepare for this lesson, you need to be familiar with your previous conic sections. We're going to start this here in a little bit by comparing parabola formulas to our other three conics. And then we still need to know how to complete the square. So you need to go back to page 223 or whatever page is listed there and watch that additional lesson if you haven't already. But seeing as this is our fourth conic section, hopefully you have at least picked up on how to complete the square, or you have taken the time to watch that lesson. Our learning objectives are to analyze and graph parabolas with vertexes at the origin and when they have been shifted to an HK. Again, to know the general form of an equations of a conic section. Understanding how the constants of the equations relate to the graph. And then lastly, we're actually going to have quite a bit, and I say quite a bit, we're going to have two applied problems involving parabolas at the end of this lesson. I'm guessing you've already used this QR code, but as a reminder, you can pause and rewind as often as you need. So this lecture is at your pace. And then you need to look at your course schedule to see when this lesson's homework is due. Now we're going to jump in and do our introduction of parabolas. Before we go over this page, let's compare our parabola formulas to the rest of these. And so I want you to pause this video, and there is one huge difference that makes parabolas different than circle, ellipse, and hyperbola. So please pause the video and see if you can find the big difference between the top three and the bottom parabola formulas. Okay, I hope you had time to pause the video or have found the difference. What makes parabola vastly different than the other three is that circle, ellipse, and hyperbola all have two squared terms. X squared, y squared, x squared, y squared, y squared, x squared. But when you come down here to parabola, these first two only have an x squared, the y is not squared. And then these bottom two have a y squared, but now not an x squared. So parabolas only have one squared term in them. Now parabolas can open up, down, left, and right. So we'll kind of go over how to decipher these formulas. But that's kind of the big difference that I want you to see, that parabola is different because it has one square term, while circle, ellipse, and hyperbola have x and y squared. Okay, so coming in here to our notes, we start off with the definition. A parabola is the collection of all points P in a plane that are the same distance d from a fixed point F as they are from a fixed line D. So that's a lot. We're going to kind of explain what all that means. It says the point F is called the focus. So notice it's called focus and not foci because we only have one focus. The line D is its directrix. As a result, the parabola is the set of points P for which this right here. So whenever I have any point at all on this parabola, the distance from my focus to that point should be the same distance as this point to my directrix line. So that's why this focus and this directrix line are so important when we go to graph them, because it's part of that definition. Now you can see as this is going to go further up, that distance is going to increase. But unlike ellipse and hyperbola, it's not a constant distance. It just means whatever this random point is, the distance from this point to the focus is the same distance as the distance from this point perpendicular to that directrix line. Okay, so when we graph, we need to graph these four things. We will graph the one vertex point. We will graph the one focus. We will graph the one directrix line, and we're not going to label that as D. We'll actually write whatever that equation is. And then lastly, we will graph what is called our two lattice rectum points, and we'll abbreviate those as LR. So what are those lattice rectum points? Well, let's go down to the bottom of the page. I'm going to explain that a little bit more. But parabolas in general are a lot more simple than your ellipse and your hyperbola. Ellipse and hyperbola had multiple variables. We had to find an A, a B, and a C. With parabola, all I need is A. A tells me everything I need to know about this parabola. So when I first started teaching this, I thought parabola was going to be the easiest because it doesn't need A, B, and C. It's all dependent on A. This actually seems to be the hardest one. And we'll go into it when we get into the next video. But, and I think it's just because there's 4 different versions, unlike ellipse and hyperbola is only 2 different versions. So the hard part is going to be deciphering which of these 4 graphs is it going to be. But in general, this should be easier because all we need is A. A tells me, and this is my parabola over here, A tells me the distance from my vertex to the focus. And let me put focus in red. Okay, so here's my focus in the middle of this, and here is my vertex. And so this distance right here is A. A also tells me the distance from the vertex to the directrix. So I am going to label this graph as D, but when we go to graph, we'll actually need to write that equation in that line. And so we will go down A as well for that distance. So once we plot that vertex, we'll go A up or to the left or the right down, but we'll go A to plot our focus and then go the exact same length to go down to plot our directrix line. And then whatever A is, we will multiply it by 4, and that gives me the length of the lattice rectum, which again, we're going to abbreviate as LR. And I might even be saying LR, so I don't have to say rectum 50 times in these videos. But my lattice rectum right here would then be right here. So my LR equals 4A. And so let's say that A is 2. I would plot my vertex. I'll go 2 in one direction to plot my focus, 2 in the other direction to plot my directrix. I would multiply that 2 by 4 to get 8. This entire length right here would be 8. So I'll go from my focus and I'll go one direction, 2A, and then I'll go the other direction, 2A, to get that entire length of 4A. And when you go to plot, you can technically plot any point on this parabola, but when you are plotting for, I'm gonna put LR here, those are my 2 LR points. When you go to plot in my math lab, you specifically have to plot these 2 points. So it's kind of tedious, but that's what we're gonna have to do.